In this video, I am going to explain the H-plane Tee. In the previous video, we have explained that how the E-plane Tee works. So let us just see the how does the E-plane is look like. So you can see here the E-plane Tee. So the arm is connected on the broader side. Okay. So broader side means what? So this is the width or this is the broader side and the arm is connected there. So now if we go to the H-plane Tee, so you can see the difference here. H-plane Tee is connected to the narrower sides and E-plane Tee, the arm was connected on this side. Okay, so it was like this. Now in H-plane Tee, what is the difference? Why it is called as H-plane Tee? So let us understand that first. So in H-plane Tee, what happens? So how the E field will be there? So E field will be oriented like this. Okay, and E field is like this, so that's why the H fields will be along this line. Okay, so along this H line the arm is connected and that is why it is called as your H plane T. Now in H plane T, if we see the graphical representation here, so so here E field is there in this direction and H field will be in this direction, and that is why it is called as your H plane T, because this arm is parallel to the H field. So what it is? Now H-plane T junction is formed by attaching a simple waveguide to a rectangular waveguide which already has two ports. So this is port 1 and this is port 2, and this port 3 is one more waveguide is added here. So where it is added, the arms of rectangular waveguide make two ports, that is called as the collinear ports, port 1 and port 2, while the new one is called as the port 3 and is also called as the side arm, or also called as the HR. Why HR? I just said because it is in line with the H field of the waveguide. Next is this H plane T is also called as a shunt T. Why it is called as a shunt T? Now you can see this image here. So this is how the H plane T is graphically represented. So it is like parallel connection to the existing waveguide. So this is port 1, port 2 and this is port 3, and it is like a parallel connection here. So that is why it is called as your shunt T also. Shunt means parallel. So as the axis of the side arm is parallel to the magnetic field, this junction is called as the H-plane T junction, and this is also called as the current junction because current is getting divided here, so it is also called as the current junction. As the magnetic field divides itself into two arms, so magnetic field is always related to what? Always related to current. So next is what is the property of that. So to find out the properties of the HMT, we have to write the S parameter first. So because there are three ports here, so there will be a 3 cross 3 S parameter will be there. So S11, S12, S13 like this, and we need to find what is the value of this S parameter with respect to this H plane T. So how do we find? So scattering coefficients S13 and S23 are equal. See, S13 means relation of this between this and relation of this port between these three ports. So both are same. So the values are also going to be same. So S13 means what? So you are giving input at port 3 and taking output at port 1. So output at port 1 and input at port 3. Similarly, S23 is what? Input at port 3 again input at port 3 and output at port 2. So basically these two ratios are going to be same, and that is why it is written here is S13 is equals to S23. So next, the symmetricity property. So what is there? S12 and S21 are same. So S12 or S21. So both are same because of the symmetricity of the network. Because we can use any port as the input from 1 or 2 and any port as the output, and the value is remain to going same. So it is like if I rotate this by 180 degree, then the image or the representation is going to be same. So that's why these two things are same. Next is S23 is equals to S32. So S23 is equals to S32. That means whatever power goes from here to here, the same power will come from 2 to 3. Again S31 and S13 also same. So S31 or S31, this is also same because of the symmetricity of the network. Now generally what happens, this port 3 is always perfectly matched. So if the port 3 is perfectly matched always, then your S33 value will be equals to 0. Why it is 0? Because that means input at port 3 and output at port 3. So whenever you give any input at port 3, because it is perfectly matched, no reflection will happen, and in this case it becomes, the value becomes 0. Okay. Now this is, we consider this as the equation 1, and after replacing all these values we get this equation 2. What is this equation 2? So you can see S11 is written, S12 is written, and S13 is written. Now instead of writing S21, so what is written here? S12, because these two are same here. Again S22 is written, then S13 is written. So instead of S23, S13 is written because these are same. So like this, after representing this, we'll get this equation number 2. Now in this equation, so the, as it is a perfectly matched and lossless, it has to follow the identity property of the matrix. So S into S conjugate, S matrix into its conjugate matrix is equals to identity matrix. So now the S parameter is this one. Now if I use it here, so S11, S12, S13 and all its conjugate, if I multiply that, then we should be getting the unitary matrix. Okay. Now from this unitary matrix we can write all those equations. So what is this equation? So if I do R1 into C1, that is multiplication of row 1 with the column 1. So this is your row 1 and this is your column 1. If I multiply, then I will get S11 into S11 conjugate, S12 into S22 conjugate. So S11 into S11 conjugate, S22 into S12 conjugate, S13 into S13 conjugate. In this case, if I multiply two conjugate values, then their mod is going to, magnitude is going to remain same. So that's why it can be written as S11 square plus S12 square plus S13 square is equals to 1, and it will take this as equation number 3. Similarly, we can write row 2 into column 2 and we will get S12 square, S22 square and S13 square equals to 1. So how it is? So this is S12 into S12. So we are multiplying row 2 and column 2. S12 into S12, S22 into S22 and S13 into S13. So we'll get equation 4 here. After this, if we multiply row 3 and column 3 and equals to 1. Why it is equals to 1? Because multiplying row 1 and C1 will give you this particular value or this value. Okay. So this is 1, that's why equals to 1 is written. Now if we multiply row 3 and column 3. So this row 3 and column 3. So there will be only two terms, S13 square plus S13 square. So right, S13 square plus S13 square equals to 1, and this value is taken as, this equation is 5 and this value is equals to 1 again. Now again what you can do, so if I write row 3 into column 1. So row 3 into column 1 if I write, so I will get S13 into S11 conjugate minus S13 into S12 conjugate. I can take an S13 common here and it will be S11 conjugate minus S12 conjugate is equals to 0. Why it is equals to 0? Because row 3 into column 1. So this is row 3 and column 1. So this value you will get equals to 0. So now from this equation, so we can get the value of S13 is 1 by root 2, because here it will be 2S13 square is equals to 1. So in that case S13 value will be 1 by root 2 again. So S11 is S11 equals to S22, that we know. Okay, because whatever happens in this port, this is the same here also. So if here S11 is 0, then S22 is 0. So the values are same, that's why S11 equals to S12. So this will be equation 8. Now in this equation 8, if I put here, so what we'll get from equation 6, we can write S13 common. So that is what I have written here. So S13 common. So we can write this. Since S13 is not equals to 0, we know S13 value is not equals to 0. And S11 conjugate plus S12 conjugate is equals to 0, right? So from this equation, this part cannot be 0. So what will happen? This part is equals to 0. So we can write S11 is equals to minus S12 conjugate. So from here we will get that S11 is equals to minus S12 if I remove the conjugate here, and S12 equals to minus S11. In this way also we can write. Now what is the value of S12? So here you see S11 and S12 is same. So if I represent that from this equation and from this equation, S11 equals to S22 and your S12 value will be what? Minus 1 by 2. Okay. So that is coming from here. Now S22 value will also be 1 by 2 because S12 is equals to minus S11 and that is equals to S22. So see here S12 value is minus 1 by 2 and from here it is equal to minus S11. So that is equals to 1 by 2 minus of 1 by 2, it will give you 1 by 2. Okay. So now here how this S12 is equals to minus 1 by 2. So from here we can write, so from this first equation we can write S11 square plus S11 plus 1 by 2 because S13 value is 1 by 2. So that is equals to 1 and substituting all the values it will be 2 S11 square equals to 1 by 2 because 1 will come this side, so 1 minus 1 by 2 will remain 1 by 2, or else we can write S11 value is 1 by 1 by 2. Now up to we got all the values from here. So whatever value we have got, if we replace that in the matrix, then we will get that S matrix will be just replacing the values of S11, S12, S13. So all these values if I replace according to which matrix? According to this matrix if I replace, then I'll get this one as my final S matrix for your HPlane Tee. Now if I write in terms of node voltage, then the output node voltage is taken as B1 if you remember my previous videos. So B1 is equals to 1 by 2 into A1 plus minus 1 by 2 into A2 plus 1 by root 2 into A3. So this is how the B1 can be calculated, B2 can be calculated, B3 can be calculated. What is this B1, B2, B3? So this is nothing but output at port 1, port 2 and port 3. So if you remember the signal flow graph lecture, there I have discussed that what is this B1, B2 and B3, A1, A2 and A3. So this is the HPlane Tee and this is how the matrix can be written. So in the next video I will show about this E-plane Tee, HPlane Tee, or it is also called as the magic Tee. So for the next video I will be discussing this. Thank you.